All right, guys, so this says without using a calculator, find the value of theta. Theta is going to be between 0 and 2 pi, which means just one full circle. So when is cosine theta equal to negative 1/2? If it helps you for this section, remember your quadrant 1 ordered pairs. So pi over 6, pi over 4, pi over 3. Pi over 6 is radical 3 over 2, 1/2. Pi over 4 is radical 2 over 2 for both x and y. And pi over 3 is just flip the pi over 6, so 1/2 radical 3 over 2. So when is cosine equal to negative 1/2? Well, the x-coordinate is 1/2 at the pi over 3 angle, so the reference angle is pi over 3. And then cosine is negative in quadrants. Remember, all students take calculus, so quadrants 2 and 3. So give me the pi over 3 angles in quadrants 2 and 3. So in quadrant 2, it's 2 pi over 3. And in quadrant 3, it's 4 pi over 3. Okay, so we do that for each one. Secant is 1 over x, right? You can also flip this around. This means this is the same as saying when is cosine theta equal to radical 3 over 2? Because remember, this is what you get. You should be recognizing some of these values if you're practicing your speed quizzes enough. So 2 radical 3 over 3 is the reciprocal of radical 3 over 2. It's just been rationalized. So anyway, we're looking for when is the x-coordinate radical 3 over 2. The reference angle is right here, pi over 6. And then we pick our two answers based on quadrants. So secant and cosine are positive in quadrants 1 and 4. So theta is the pi over 6 that's in quadrant 1, which is just pi over 6. And the pi over 6 that's in quadrant 4 is 11 pi over 6. So I think better in terms of sine, cosine, tangent. So that's why I flipped this. Instead of secant, I looked at it as cosine. Same thing with this one. Instead of cosecant equaling negative 2 radical 3 over 3, we could say that means that sine theta is the reciprocal of that, negative radical 3 over 2. Remember, sine is y. So for a reference angle, which ordered pair has a y coordinate of radical 3 over 2? That's pi over 3. And then sine is negative in quadrants 3 and 4. So give the quadrant 3 and 4 version of the pi over 3 angle. So quadrant 3, it's 4 pi over 3. Quadrant 4, 5 pi over 3. If you're unfamiliar with these angles, like if it's taking you a long time to figure out the quadrant 3 pi over 3 angle, it just comes down to practice. So filling in your common angles, practicing all the speed quizzes, using those flashcards. It's really just practice to get these figured out. There are lots of patterns to notice. Okay, when is sine theta radical 2 over 2? So when is the y-coordinate radical 2 over 2? That should be an easy alpha to pick out. The reference angle is pi over 4. It's the only angle in quadrant 1 that has radical 2 involved. And then sine is negative in quadrants 3 and 4. So give the pi over 4 angle in quadrant 3. So that's 5 pi over 4. And give the quadrant 4 angle 7 pi over 4. When is tangent theta undefined? Remember, tangent is y over x. So to be undefined, the x-coordinate needs to be 0. The y-coordinate when x is 0 will either be plus or minus 1. That part doesn't matter. So we're looking for x to be 0. So if you fill in these 4 ordered pairs, the non-quadrant angles, the x-coordinate is 0 at the top and the bottom of the circle. So theta, I don't need reference angles for this because we're not into a different quadrant. It's just what are the two answers. So theta is equal to pi over 2 at the top and 3 pi over 2 at the bottom. Cotangent is radical 3 over 3. So for this one, I would unrationalize this. Like this was radical 3 over 3. Before it got rationalized, it was 1 over radical 3, right? Because if I rationalize that, I get this. So the reason that's worth pointing out is because cotangent is x over y, and our ordered pairs don't have a 3 in them. They only have 1s and radical 3s and 2s. So we're looking for which one of these three ordered pairs has an x coordinate of 1 or 1/2 and a y coordinate with radical 3 on top or radical 3 over 2. So that's right here, right? X numerator is 1, y numerator is radical 3. So the reference angle is pi over 3. Cotangent is positive in quadrants 1 and 3. So for theta, the quadrant 1 angle is pi over 3, and the quadrant 3 angle is 4 pi over 3. When is secant equal to -1? You can flip this one if you want to. That's the same as saying when is cosine theta equal to the reciprocal of -1 is -1. So when is cosine? When is the x coordinate -1? There are not two answers for this. The only time the x coordinate is -1 is out here at pi. So theta equals pi. Cosecant equal to negative radical 2. So again, you can flip this if you want, but with radical 2, the only angle that has radical 2 in it is pi over 4. So that's your reference angle automatically. So I don't really bother with flipping anything if radical 2 is involved. And then the negative, remember, cosecant goes with sine. So sine is negative in quadrants 3 and 4. So theta is the pi over 4 angle that's in quadrant 3 and 4. So 5 pi over 4 and 7 pi over 4. When is cotangent theta equal to 1? Cotangent is x over y. Now, we don't have a 1 over 1, but remember, cotangent is equal to 1 when the x and y are the same value. So this is another one that the more you practice these speed quizzes, the more familiar you get. But when tangent and cotangent are equal to 1, that is the pi over 4 angle, because 1 was really radical 2 over 2 divided by radical 2 over 2. So that happens at pi over 4. Cotangent is positive in quadrants 1 and 3. So our answers for theta are pi over 4. And then the quadrant 3 version of that is 5 pi over 4. When is cosine equal to 0? When is the x coordinate equal to 0? So I don't want to keep scrolling up and down here. The x coordinate is 0 at the top of the circle and the bottom, but not on the sides. On the sides, it's plus or minus 1. So theta, I don't need a reference angle if it's sine or cosine equal to 0 or 1 or something like that. If you're on a non-quadrant angle, you can just get right down to the answer. So the top of the circle is pi over 2, and the bottom is 3 pi over 2. Cosecant theta equal to 2. This one I'll flip because that's not a radical 2. So this means that sine theta is equal to the reciprocal of that, 1 over 2. So looking at my three ordered pairs, which one has a y value of 1/2? Should be pi over 6. Scroll back up here for a minute. Pi over 6, right? And which quadrants is sine positive in? Quadrants 1 and 2. So our answers for theta are pi over 6, and the quadrant 2 angle is 5 pi over 6. When is sine theta equal to negative radical 3 over 2? So when is the y coordinate equal to negative radical 3 over 2? The quadrant 1 angle, the reference angle that we're looking at, should be pi over 3. Excuse me. And when is sine negative in quadrants 3 and 4? So your answers for theta are the quadrant 3 version of pi over 3, so 4 pi over 3, and the quadrant 4 version, which is 5 pi over 3. All right, and then last question down here. If we had to solve for all theta, not just angles within one circle, how do we adjust all of these answers? So if I wanted to know for this last one, these are the two angles within one circle. We talked about this in our notes. The idea here is list all possible coterminal angles. So how do we do that? Because angles, there's an infinite number of answers, right? So all you have to do for this, and our AP test uses this a lot, they just want you to say that theta, so say number 12, theta is equal to 4 pi over 3 plus a full circle 2 pi times k. And the idea is that k is an integer. They'll write it in words on the AP test if it's multiple choice, or you can write it in words too. This just means you can add or subtract any number of circles, 1 circle, 2 circles, a billion circles to this angle, and you'll land in the same place. So the sign of that angle, whatever it is, will still be negative radical 3 over 2. You do that for each answer you have. So it's hopefully it's easy to remember. It's just plus 2 pi k. K is an integer. In our notes, we talked about the symbol version of that. K is an element of the integer number set. Integers are denoted by a capital Z for some reason. I is taken for irrational numbers. Okay, and then using a calculator, you can either solve algebraically or graphically. I'm going to solve graphically because it's faster. So if you want the algebraic version, that's something that we can go over in office hours, but I really don't see any purpose to going through this algebraically. So if I want to know when sine theta is equal to this decimal, I'm going to put sine x into y1. I'm going to put the decimal into y2. I'm going to fit the window. The x min is always 0, and the x max is always 2 pi. And then I'll adjust my y window just to make sure that it captures this value and gives me a little bit of space. So make sure you're in radian mode. If not, press mode, change to radians. Go to y equals, type in sine x, and then the decimal, 0.4014. Set your window 0 to 2 pi. It doesn't matter what it counts by, so I'll just let it count by ones. I don't need the y's to go from negative 10 to 10. I mean, you can, whatever, but I only need to capture this value. So I'm just going to say go from 0 to 1. And then I'll press graph. And I'm looking for the 2 points of intersection. So enter, enter, enter. Found the one on the right first. So theta is about equal to, round to 3 places, and these answers are in radians because we are in radian mode. For our AP test, you will not be asked to do anything in degrees as far as I know, so it's all radians. 0.413. Like, we shouldn't be, for AP exam, we should not be switching the mode in our calculator. But I will have you guys that morning make sure that you are in radian mode. Okay, so that's number 13. Next one, I'm just going to change this out. Cosine of x and negative 0.5736. I do need a window adjustment then, so my window should be, maybe instead of 0 to 1, I'll go negative 1 to 1, because that's going to capture my 2 points there. A little preview for what a cosine graph looks like. That's what we're doing after we have this test. We'll be graphing these functions. Again, it found the one on the right first. The order doesn't really matter. Theta is 4.101 radians. And the other answer, you've just got to get your cursor closer to the point of intersection that you haven't found yet. 2.182. Okay. Let's do a tangent one. Change that to tangent x. Change this decimal to 3.271. Oops, I just hit graph. My window, though, only goes negative 1 to 1, and I need it to capture 3. So let's just bump the x or the y max up to 4. and press graph. So there's no zooming for these, you'll notice. I'm not zoom fit. If you do zoom fit, it goes crazy because these graphs go up forever and it like zooms way out. Okay, so sure, first curve, second curve, it's going to find this one, 4.416 radians, and the other one, I'm going to hop down to the red line just so I just press down to hop to the red line, just so I can get, I think, faster, closer to this side. So enter, enter, enter. Oop. That did not work. All right, I guess I'll be on the blue curve and I will just arrow to the left until I get, it's gonna hop down to this other line at some point. There it is. Enter, enter, enter. Okay, 1.274. Now, what do we do? Why do I have 6 of these? I wanted to make sure you practice the reciprocal function. So if you're doing the reciprocal function, there is no cotangent key. And you can't just, so to get around this, you need to rewrite the problem. Tangent theta is equal to the reciprocal of this. Well, the reciprocal of a decimal is not a quick, easy thing to flip. So we will just say 1 over negative 0.8041. That is the reciprocal of that decimal. So tangent x, fine. And then into y2, 1 divided by negative 0.8041. That's the only thing that changes. And then let's hit graph. Now, how do I see what 1 divided by that value is? If you want to adjust your window better on your home screen, see what this comes out to. 1 divided by negative 0.8041. So it's low. The reason it's not showing on my screen is because I stop at -1. I need to go a little lower. So let's bump this down to -4, and then maybe that'll fix, well, I guess that won't fix the rest of my problems, but we'll see. All right, so those 2 points of intersection. Enter, enter, enter. So theta is 2.248, and this is the tedious part on my computer. I think it arrows faster on your own calculator. There it is. Enter, enter, enter. 5.389 will round up to 90. So I need to make this cosine theta is equal to 1 over 20.14. So I change this to cosine and change this to 1 over 20.14. Now, 1 over 20.14 is something small. So I'm sure that being between -4 and 4 in my y window is fine. Yeah, so it's practically 0. Okay, so find this intersection. Enter, enter, enter. So theta is about 1.521, and $4.762. All right, last one. Cosecant goes with sine, so sine theta is equal to 1 over negative 5.6789. One over negative 5.6789. You can tell I was sick of making decimals. So then just press graph. And yeah, 1, 2 intersection points. Finding the intersection between 2 points is a calculator skill that obviously we need for our AP test, but we use it a lot for calculus too. So it's good to be just really comfortable doing this. I'm hoping that after this year, it's just natural for you to be, if you're allowed to use a calculator, to just solve it by graphing if it's easy to graph. 6.106, especially if you're given a domain like we are for this one, 0 to 2 pi. Now, I could have asked that question again. What do we do to these to make them infinite outside of one circle? You could add 2 pi k to all of these angles, and now you've found every solution for theta instead of just those between 0 and 2 pi. All right, that's it for this homework assignment.